see this minimum sum difference problem where uh, we will be given with an array, okay, and you have to tell what is the minimum difference between two subset possible. So minimum difference, and that too between the two subset is possible. So let's take this array and start seeing. So ARR array which has 1, 6, 11, and 5 as an element. If you see one possible subset, that is 1, 6, and 5, and you take remaining in one subset which is 11. So sum of this is 12 and sum of this is 11. So if you do this minus this, the difference will be coming as 1. But you could have also taken subset as 1 as only 1, and in other subset you would have taken remaining other elements. So this subset sum is 1, this 17 and 5 22. So 22 minus 1 is 21. So see, we have to find the minimum difference, right? This is not the minimum difference. This one is a minimum difference, right? So how can we actually achieve this using the concept that we have learned in the previous lectures, right? So okay, so in equal sum partition problem, what we were doing, like we are given with an array, okay, and we used to find two subset S1 and S2 such that S1 minus S2 should be equal to 0. Okay, right? So this was our intuition or the concept that we have used in equal sum partition. But here we have to see minimum difference. So minimum difference between two subsets. So we have to look for this, right? So again here we are given with an array, okay, and we have to find two subset S1, S2 such that S1 minus S2 should be minimum, right? Here we don't know what is minimum. How can we find minimum? So let's see that. Okay, before jumping there, let's see one thing. Okay, so if we have one array, okay, some array, okay, let's consider the same one, 1, 6, 11, and 5. Okay, and we have to construct this two subsets, right? So let's construct the first subset S1, the second subset S2. Okay, and and we want minimum difference, so S2 minus S1 should be minimum, right? Since we don't know what S2, S1 or minimum is, like it's very hard for us to find, right? But let's see if we can eliminate any one of the variables. So we certainly know that S1 minimum value, the subset on minimum value can be 0 and S2 maximum value can be full array. Okay, so here is the scenario. We have taken nothing. In that case, the sum will be minimum, right? So 0. And if we take all the elements, right, then sum will be 16, 23, right? So if you see, this is the range in which our minimum value can come, right? 0 to 23. So we know that. So if S1 is this and S2 is this, okay, so what will be, uh, so we can write S2 as range minus S1. Why? If you say, so S1 plus S2 equal to range, right? Or the sum of the whole array. So S2 is equal to range minus S1, right? This one, highlight this. So if we write in place of S2 as range minus S1 is equal to min. So range minus 2S1 should be minimum, right? So we certainly know one thing, that range is fixed value. Okay, it can be either 23, 10, 15, anything, but we can change S1. Okay, and if we have to minimize this whole thing, then we have to maximize this one, S1. Okay, how I'm saying this is, like, let's say if S1 is 2, S2, S1 is again, let's take three cases. Case 1 where S1 is 2, case 2 where S1 is 4, and case 3 where S1 is 6. Okay, so if S1 is 6, what will the value? Range is 23 minus 2 into 2 is 4, 19. This is 23 minus 4 into 2, 8. This is how much? 15. This is 23 minus 12. This is 11. So if you see, when we are increasing the value S1, our range is becoming minimum. Like, it's not minimum, it's decreasing, right? So in order to get the minimum value of the difference of the subset sum, we have to maximize this S1, correct? Let's draw a number line. So now we know that this is 0, this is range. Here S1 can be or S2 can be. So S1 and S2 will be lying inside this range. Okay. And in order to, let's write the array also so that we can have 1, 6, 11, and 5, right? Let's write also this as 1, this has 2, this has 3, this has 4, this has 5. Okay, this has 6, 7, 8, 9, 10. Similarly, the last value will be 23, right? So we have to maximize this S1, right? So if you see, S1 can be maximum 12, right? Hmm. Let's let's take a smaller example. Okay, this is becoming very difficult for this. This is very difficult. Let's take a smaller example. Let's take a smaller array, 1, 2, and 7. Okay, 3, 1, 2, and 7. Right. Let's start. Let's take an array 1, 2, and 7. Okay, total sum of this array is 10. Okay, so the range can be from 0 to 10, right? Let's write 1, 2, 3, 4, 5, 6, 7, 8, 9. So what was the minimum value? Range minus 2s1, right? So let's see, is 1 is possible? One subset, like the subset with a sum of 1 is possible. Yeah, that's possible. So let's mark this as green. 2 is possible. Yeah, 2 is also possible. Is 3 is possible, and that's also possible. 4, no, that's not possible. Is 5 possible? No. 6, no. 7, yes, it is possible. 8, 7 plus 1, 8 possible. 9, 7 plus 2, 9 is also possible. And 10 is also possible. So these are the 8 possible values of S1 or S2, right? And if you see, they are appearing in pair. For 0 we have 10, for 1 we have 9, for 2 we have 7, and for 3 we have, okay, so for 3 we have 7, and for 2 we have 8. Okay, so if you see, the sum of these two values will be always 10, and they appear in pair. If S1 is this, S2 can be this. If S1 is this, S2 can be this. If S1 is this, S2 can be this. Okay, so let's consider this part as S1 and this part as S2. Okay, so what is the maximum value of S1? In which, on which, what is the maximum value of S1 on which uh, like subset is possible for the given array? So this is 3. So if you put range is here 10, minus 2 S1 is 3. So that is 10 minus 6 is equal to 4, right? So this is the minimum difference that we can get for. And what is example of this is 1 and 2 in 1, and then 7 in 1. So this is 3 and this is 7. So 7 minus 3 is 4, right? So this is the solution. Okay, and how we can go with solving this answer? So now we have the concept. So now let's see the similarity. Okay, so if we talk about the similarity, let's not talk about the similarity first. Let's see the subset problem, right? Subset problem. Let's take this one only. Array was 1, 2, and 7. Okay, and range is 10. So let's draw. That's very big, right? Okay, so we have sum till 7, then we have array elements, variables 1, 2, and 7. In the same convention, false, 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 true, 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 true. Right. 1 is possible, right? These all will be false. For 2, 1 can be formed, right? It can be 2 can be formed, right? 3 can be formed, yeah, formed. Rest all will be false. When we have 7, so true, 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 no, false, false, false. Now 7, that's true. 8, true. Can 9 be formed? Yes, yes. So what do we need? We need this last row, right, in order to get our answer. And that too in last answer, we will need only this half part, right? Because S1 will be less than range by 2, correct, or equal to. If you don't get how it is, so that's very simple. We have to get minimum difference, right? So if difference is 0, then S1 and S2. If difference is 0, then S1 is equal to S2, right? Which can be range by 2, which can be only possible when range by 2, right? And since we are talking about the minimum range here, no? So S1 should lie in this part of the block, and that too we need only this column for our answer. Okay, so what we will do, we will traverse this row until range by 2, and we'll traverse from behind, and we'll look for the first non false or first positive case. Okay, since we got at 3, we'll take 3, and then we'll do range minus 2 into 3, and that will be the answer, right? Whatever answer is coming. So this is the approach that we are going to follow. Let's move to this coding part. Let's take this. Okay, right here itself, array is 24713. Let's create one new array for this question. 1, 2, and 7. Okay, and so int mini ml is a variable where we are storing the answer, and minimum, let's write the function as minimum subset difference, pass array size 3. That's it we need. Okay, so see out minimum difference between two possible subsets is okay. So now we have to find the sum of the array. So for int I equal to 0, I less than size I plus plus. We have to define one variable also equal to array of I. So int sum equal to 0. Right, so now we have the sum. So we'll create one matrix or table size plus 1 and sum plus 1. Now we have, let's define it now. So for int I equal to 0, I less than equal to size I plus plus. For int j is equal to 0, j less than equal to sum j plus plus. Now let's initialize. So if I equal to 0, then t of I comma j, okay, equal to false. If j is equal to 0, then t of I comma j is equal to true. So here we have initialized it. Okay, we come here. If I is greater than 1 and j is greater than 1, and this is the one now, equal to also. Then what we are doing is, if array of I minus 1 is less than equal to j, then t of ij is equal to t of I minus 1 j minus error of I minus 1 or t of I minus 1 j. T of I j is equal to t of I minus 1, then t of j. For loop is ending here. Now we are not returning anything as of now. Now we have to traverse at the last index. So t of last is size, right? 0, 1, 2, 3, right? Size, and we have to iterate. Let's take in j or k variable. Anything is fine. And for int k is equal to sum by 2 k, k greater than 0, k minus minus. Now what we are doing, this will have some value, right? So this, let's set 5 if we are more concerned about the true cases. So जैसे ही होता है return 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 what, return k, right? ये तो कोई ऐसा केस रहेगा ना जहाँ ट्रू होगा. Correct. Let's run and see this. Minimum possible 3 that is coming, but let's also, oh, that's fine.